On a Friday afternoon, and if I love seeing your faces, so thank you for putting on your video. If you have the opportunity and feel like doing it, I would love to see your faces. So again, my name is Mrs. Landon, and I work at Colorado Springs Utilities. And the library asked me to come speak to you today all about water. Since I'm a water scientist, they asked me to come talk to you about water. So that's what we're going to do today. First question, though, is how many of you have ever heard of Colorado Springs Utilities before? Raise your hand if you've ever heard of Colorado Springs Utilities before. Oh, good. Most of you have. That's excellent. For those of you that don't know who we are your utility company, and it's our job to make sure that you live in a nice, comfortable home and have everything you need as far as utilities. Now, there's four things that we provide for you. And I'm sure you could guess water is one of them, right? That's why we're talking about it today. So water is one of the things we do for you. But then there's three other things we do for you not related to water. Anyone have a guess what else we do for you? All right, Hunter, I see your hand up. Hunter, can you unmute yourself and say what else do we do?
Electricity?
Yes, we are your electricity company. We make electricity lots of different ways, and then we send it to your house. So yeah, we supply your water that you use for drinking and shower, and we supply the electricity you need for your lights and computer. Now there's two more things we do for you. Who wants to guess another thing that we do for you? Okay, I see Juliet and Titus. Can you tell me, besides water and electricity, what else does Colorado Springs Utilities do for you?
Heat.
Yes, we supply the natural gas that you use for heating your home. Very good. Okay, so we give you your water, we give you your electricity, we give you your natural gas. There's one more thing that we do for you, and it's kind of a tricky one, so I'll give you a hint. Think of us every time you flush the toilet. Hmm. What else does Colorado Springs Utilities do for you? All right, let's see. I see Jennifer Raymond, young person in the corner. I'm sure your name isn't Jennifer, but what do you think?
My name's Ansel, and
Ansel.
my mom's name is Jennifer. You also do sewage, and you
Yes.
empty our sewage, and you make the route lines for our sewage, and you also, one more thing, you like if you're having construction done, you will mark where the electricity lines are.
Very well done, Ansel. I appreciate that. Yes, we are your sewer company. We like to call it wastewater. That sounds fancier than sewer, right? But we take care of your used water. And yes, if you ever have anything that you need to do in your yard that requires digging, then you need to call 811 first, and then we'll come out and mark all your lines so you don't accidentally hit an electric line and electrocute yourself or something terrible like that, right? So make sure before you dig, you call 811. I see a hand up. Aiden, yes.
Have you ever gone out to a layaway?
Sure we have. You might have seen our trucks out there. And then it has like the Colorado Springs Utilities logo on there. Colorado Springs Utilities logo looks kind of like this on the trucks.
I'm just asking because my grandpa made his house all by himself, and I don't know if he got
Oh,
any.
he might have called to make sure he didn't run into something buried. Well, today we are going to talk about water. And again, like I said before, I'm a water scientist and I love doing experiments and demonstrations. This is a little tricky being virtual, but we're going to give it a try. And you'll see on my table behind me, I have some stuff. I don't know, can you see the stuff on my table? We're going to try to do a few demonstrations today. I do want to introduce you to my friend Dewey. Dewey is a water drop, and he is the Colorado Springs Utilities water mascot. He tells everyone how important it is to use water wisely. And he's got this cute little voice. He says things like, "Save me, I'm a big deal." He's funny. Anyway, he's going to sit here and listen in. And at the end, if there's time, he has a game he wants to play with you guys. So we're learning all about water, and probably in the schoolwork that you're doing, you're learning about how humans depend on Earth's resources, right? And water is one of those Earth's resources that is why we're even alive, right? Water is the key to life. Clean water is what people need. In fact, does anyone have a guess? How many days can you live without water before your body gets so dehydrated that you could actually die? How many days? Show me with your fingers. Hold up your fingers. Let me see. How many days? More than one day. Oh, I think I see some of you have 3 fingers up. You're correct. That's it. 3 days. If you don't drink any water or anything that has water in it, after 3 days, your body is going to become dehydrated. You're going to lose water out of your body. And if you don't refill it, you're going to get dehydrated and you could actually die. So you need water more than anything else to stay alive. Well, no, you need air too, but water's right up there with the most important things you need to stay alive. So we're going to learn about water today. I love water. Okay, let's start off with what is water made out of? Maybe some of you know. Water is made out of these tiny things you can't see called molecules, right? And the water molecule has 3 atoms in it. Does anyone know what those are? What are water molecules made out of? All right, it looks like Ansel. Would you know? Why don't you answer?
2 hydrogen and 1 oxygen.
Excellent. Exactly right. So I'm going to make a model of a water molecule. Let's pretend this is an oxygen atom, right? It's in the air, oxygen. Is this water yet? Nah, it's just oxygen. To make water, we need to add the hydrogens. You guys have heard of H2O before? That's the chemical formula for water. That's what water is actually made out of. 2 hydrogens and 1 oxygen. So H2O, right? So we'll add a hydrogen. Is this water yet? No, this is OH. That's not water. Water needs 2 hydrogens. We're going to stick them on there. This is what water would look like. If you could see a water molecule with your eye, this is what it would look like. 2 hydrogens attached to an oxygen, which kind of looks like a shape you may have seen before. Anyone have a guess? What does this look like to you? Aiden.
Mickey Mouse.
Yeah, Mickey Mouse head, right? I agree. And so if you hear me talking about Mickey Mouse today, I'm talking about water, right? Mickey Mouse molecules. That is what water is made out of. So if you could actually look inside this water here, you'd see billions and billions of things that look like Mickey Mouse heads all stuck together. Yeah, that's what it would look like. All right. So water, very important. Water is important. It keeps us alive, right? We need to drink water. In fact, doctors ask you to drink how many cups of water a day to be fully hydrated? Does anyone have a guess? How many cups of water a day do the doctors recommend that you drink to be fully hydrated? Show me with your fingers. How many cups? More than 4 cups. More than 5 cups. Oh, I see it. 8 cups. 8 cups of water a day. That's what the doctors recommend. And here's why. Your body is made of water. Now, sure, you have some bone and skin and other things too, but there's a lot of water inside your body. In fact, find some skin on your body somewhere. Do you think there's water in your skin? Yeah, sure enough. Yeah. How about some hair? Find some hair. All right. Do you think there's water in your hair? Sure. Otherwise, it would just break, right? Yeah, there's water in your hair. How about a bone? Find a bone on your body somewhere. Do you think there's water in your bones? Absolutely. Yeah. Do you see your veins? Do you think there's water in your blood? Oh, sure. Lots of it, right? Yeah, there's a lot of water in your body. In fact, who wants to guess? How much of your body, what percentage of your body is made out of water? All right, I don't see all of you up there, but I see Juliet's hand up. Juliet, can you tell us?
95%?
It's less than that. If we had 95% of our body made out of water, we'd be related closely to jellyfish. So it's less than that, but it's pretty high. Who wants to take another guess? Colin, how about you? Colin, what's your guess? What percentage of your body is made out of water?
10/4.
10 fourths. I got to calculate that into percentages. 10 fourths. It's closer to 2/3, which is close to, it's about 2/3. So kids have a little bit more than adults, but on average, 70% of your body is made out of, yeah, Mickey Mouse molecules. That's right. So we have more than half of our bodies made out of water. Now you're losing water all the time, right? In fact, everybody take a deep breath in, breathe out through your mouth. Did you see them? Mickey Mouse molecules just came right out of your mouth. Every time you open your mouth and say something or breathe, you are losing water out of your body. Okay, there are other ways you can lose water out of your body. Who can tell me another way that you can lose water out of your body? Don't be shy. Somebody has their hand up. Let's go with Hunter. Hunter's going to unmute himself. All right. What do you think, Hunter? What's another way that you lose water out of your body?
Sweat.
Yeah, sweating. You lose water when you sweat. Uh-huh. William, I see you there. William, what's another way you can lose water out of your body? William with the red hoodie are on mute. He might be tapping.
Cut.
What's that?
By getting a cut.
Yes, if you get a cut and you bleed and your blood comes out, you can lose water that way. Yeah, lots of ways. Crying. You can lose water out of your body when you cry. And then there's something that all of you do every day, which is go to the bathroom, right? You definitely lose water when you go to the bathroom. Now, that means you have to refill yourself. Every day you need to drink how many cups of water again? Show me with your fingers. 8. 8 cups of water a day to keep refilling that water back inside you, right? You need a bunch of Mickey Mouse molecules inside you to be healthy. Okay, now let's take a look at the Earth. Here we go. This is the Earth. And you see all the light blue on the Earth. Well, that's the parts of the Earth that are covered in water. And then the colored areas, well, that's the dry land. In fact, if we look, let's see, where's the United States? Here we are in yellow, right? You live here. So as I turn the Earth here, what do you think? Is there more water covering the surface of the Earth or more dry land? Colin, what do you think?
More water.
Definitely more water. We're called the blue planet. And the reason why is because from space we look blue. Because we have so much water covering the surface of the Earth. Look at these huge oceans, right? Lots and lots and lots of water on the Earth. And that is why we have life here. Now, this is good news for you because you're supposed to be drinking 8 cups of water a day, right? And so we need lots of water for all the people that live on the Earth. And luckily, we have lots of water. Oh, but wait. Is all this water on the Earth the kind of water people can use for drinking? No, no. A lot of the water on the Earth people cannot use for drinking. And there's a particular reason why. Who wants to tell me what is wrong with some of the Earth's water? Why can we not drink some of this water? And I apologize, I can't see everybody up here, but is it, I see a hand up somewhere. Colin, I'm going to call on you again, Colin. Why can't we drink all this water?
Is some has salt.
Exactly right. Some of it has salt in it, and people cannot drink salt water. Oh yeah, you can drink a little bit of salt water, but if that's all you drank all day, then the salt actually pulls the water molecules out of your organs and dehydrates you faster. So you can't drink salt water, and salt water is ocean water. Look at these huge oceans. This is all salt water. People need fresh water. Fresh water is found in freshwater lakes like Lake Superior and rivers, streams, rain, but oceans are salty. So all this salty ocean water is not available for people for drinking. So we're going to do a little demonstration. Let's pretend that all the Earth's water is inside this bottle right here, right? Well, a lot of it is in the oceans, which is salty water. People can't use that. In fact, does anyone know what percentage of all the water on the earth is salty? How much of the earth's water is salty versus fresh? Does anyone have a guess? What percentage of the earth's water is salty? I'm just going to call on William. William, just make a random guess for us, would you? Tell me, what do you think? How much of the earth's water is salty? Do you think like half of it? That'd be 50%? More than that? Less than that? Take a guess, William.
Probably half.
Half, which is 50%. Excellent guess, William. But you know what? More than half the Earth's water is salty water. So I'm going to need another guess. All right, somebody else guess. It's more than 50%. I'm going to pick on Porter and let's see, Porter and Evelyn. Do you have a guess? What do you think?
90%.
You are almost right. Excellent guess. It's actually 97% of all the water on the earth is salty. 97%. My gosh, that's almost all of it. Almost all the water on the earth is salty water, which people can't use for drinking. Oh my goodness. All right, now if you're doing the math, then you can figure out how much of the earth's water is fresh water, right? So if 97% is salty, the amount that's left over, that little bit that's left over, is fresh water. And that, if you're doing the math, comes to 3%, right? So 3% of the Earth's water is fresh water. That's the kind people need. Now I'm going to do a demonstration. If this is all the water on the Earth, which by the way, for all of you that like really big numbers, the amount of water on the Earth is 326 quadrillion gallons. We're going to pour 3% into here, which represents our fresh water. This is fresh water on the earth. This is salt water on the earth. People cannot drink salt water, so we're going to just set that aside. And we're going to think about this 3% of fresh water, because that's what people have to have is fresh water. And animals too. Your dog, your cat, they need fresh water as well. So this 3% of fresh water on the earth, do you think all of this 3% of fresh water on the earth is available for us to drink? No. Some of the fresh water is not available to us because it's frozen solid. I'm going to pour off 2% of this because that is how much is frozen. 2% of the Earth's water, fresh water, is frozen. Down here at the Antarctic in big ice sheets, up here on the Arctic Circle, the North Pole, glaciers, icebergs, it's fresh water, but it's locked up in solid form, far away from where people live. We can't use that for drinking either, so I'm going to set that aside. Okay, so we have 1% of the Earth's water left in this cup that people have to share. Do you think this 1% of fresh water right here, all of that available for people? Mm-mm. Here's the problem. Of that, a whole bunch of it is stuck way underground, too far for us to drill down and get it, or way up in the clouds, or has gotten polluted. Now, what does polluted mean? Does anyone have a guess? Colin, can you tell me what is polluted water?
It's water that has chemicals in it that we can't drink.
That's right. Polluted water is water that has something in it that would be unsafe for people to drink. It could be chemicals like gasoline and oil. It could be bacteria that you find in sewage or things like, you know, the biggest problem around Colorado Springs? Doggy doo-doo. People don't clean up after their dogs when they take them for a walk. And then it washes into the streams and it makes the water polluted, right? So we don't want bacteria, germs, chemicals, all kinds of things can pollute water. So that is not available for drinking. That means of all the fresh water on the earth, only this tiny little amount left in this cup is what's actually available for people to use for drinking. This tiny amount comes to 0.03%. It's tiny. This is not a lot of water. And that's what we all have to share. Oh my goodness. So if all of us are sharing these few little drops of water here, do you think we're going to run out of water on Earth? No. Some of you are shaking your heads. No, you're right. We are not going to run out of water on the earth because of something nature does. Nature has a way of cleaning water back up and recycling it so it can be used again and again and again. Now, we still only have this tiny little bit to share amongst all of us. But that little tiny amount keeps getting refilled through this natural cycle. And we call that the water cycle, right? Or the hydrologic cycle. Either one. I'm going to show you a poster. Hang on. Of the water cycle. Now, the water cycle is nature's way of taking liquid water, changing it to gas, letting those molecules condense again and come back to Earth as fresh precipitation. And then we can use it and it gets recycled and recleaned over and over again. Now, has anyone ever told you, hey, you just took a shower in dinosaur pee? What? Is that possible? Yeah, actually, maybe. Who knows? Long, long time ago when the dinosaurs were living, maybe some of them drank out of this lake here. And then that water went inside the dinosaur. Does it stay inside the dinosaur forever? No, right? It's going to come out of the dinosaur somehow. And then that water molecule can travel around the water cycle and get recleaned. Anytime water goes from liquid to gas, we call that evaporation, it goes back to the pure form of H2O. So let's say that this water molecule was in the ocean, covered in salt. Can you drink salt water? No, right? But as the sun shines down on the surface of the ocean and water warms up, what does water do? It turns into a gas and evaporates. Now, does all that salt stuck to the water molecule evaporate too? No. Salt's too heavy, stays back in the ocean. Only Mickey Mouse evaporates. Only H2O goes into the air, becomes a gas, and then up in the sky, he finds his friends. Let's see. Do we have any friends? Friends. And then they stick together, they condense, they make clouds. Now, out of clouds comes fresh water. We call that precipitation. There are 4 kinds of precipitation. Who wants to name one kind of water that comes out of a cloud? What's one type of precipitation? Colin, tell us.
Snow.
Snow, yes. Oh, and at Colorado Springs Utilities, snow is our favorite kind of precipitation. I'll tell you why in a minute. Okay, snow is one. What's another type of precipitation that comes out of a cloud? Let's see. I'm going to randomly call on Hunter. What else comes out of a cloud besides snow? What do you think, Hunter?
Hail.
Yes, hail. That's a very interesting type of precipitation. Okay, and I'm going to just pick on people. Let's see. How about...
Ansel has his hand up.
Oh, that, see, it's
that
very hard
helps.
for me
Yeah, I
to...
know.
Yes, I don't see the kids very well. Ansel, what's another type of precipitation?
Slush.
Yes, we call it sleet. Okay, so we got snow, hail, and sleet. There's one more type of precipitation. And Juliet, can you tell me?
Rain.
Rain. Exactly right. And that is water that has been cleaned up through the water cycle. Mickey Mouse is pure, and that comes back to Earth and refills that tiny little bit that people can use for sharing. Okay, so that's the water cycle. Very important. It's the reason you're alive today. Now, can you drink the rain out of the sky? Sure you can. The water cycle has cleaned it up for you. It's pretty pure. You can here in Colorado Springs because we have good air quality here. If you go to places with a lot of air pollution, then Mickey Mouse picks up some air pollution on the way down. Maybe you don't want to drink the water there. Like, for instance, China has a big problem with this. You don't want to drink the rain in China because it has picked up air pollution on the way back to Earth. But here in Colorado Springs, if it's snowing outside, you can open your mouth and start collecting snowflakes on your tongue. If it's raining outside and you're super thirsty, just open your mouth and enjoy yourself. Now, here's the thing though. Once the rain hits the ground, then it has a chance to pick up some dirt, and germs like to stick to dirt. So if there's any little tiny bits of dirt in your water, don't drink it because you don't know. Maybe there's some germs that got in there and it ends up giving you stomach aches and diarrhea or something like that. Just drink the water out of the faucet. The water out of the faucet is water that Colorado Springs Utilities has cleaned at our water treatment plants. And we pipe it to your house. And we have to test it before we send it to you to make sure it is truly safe to drink. So your water at your home is safe to drink. Any water coming out of the faucet at your home or your school or the store or wherever is supplied by the water treatment plant, and it has been cleaned and tested to be sure it's safe. Okay. All right. So water. Now we collect water and then we treat it as a water treatment plant to make sure there's no dirt, no germs in there. And then we send it to your house. Where do we get the water from to treat and clean and send to you in the first place? Does anyone have a guess? I think I saw Titus's hand up. Titus, do you want to tell us? Where do we get the water from? Yeah, you.
The Colorado River.
The Colorado River. My gosh, you guys are pretty clever children. Now, the Colorado River is the source of most of the water you're using in Colorado Springs. It's true. Does the Colorado River flow through Colorado Springs? No, it's way over on the other side of the state. But it happens to be the biggest river in the state. It happens to have a lot of water in it. And because the streams in town don't have enough water in them, we have to go all the way to the other side of the state to get your water and then bring it over here to clean it and serve it to you. All right, so let's take a look at this picture one more time. Let's imagine that this mountain right here is Pikes Peak, and Pikes Peak has snow on it, right? In the springtime, that snow warms up and it melts, and then that water is going to run down the mountain. At the bottom of the mountain, we have built something called a dam, which is like a large wall of rocks and concrete, and it traps the water as it comes down the mountain behind the dam, and it makes a lake called a reservoir. And that's where we store the water. So when you need water, we take the water out of the reservoir, we clean it at the water treatment plant, and send it to your house. But do you think Pikes Peak has enough snow on it to melt into enough water for everyone that lives here? No. That's why we have to go all the way to the other side of the state to the Colorado River, and then we have to collect that water and bring it all the way to town. It's quite a journey to get here. But your water has started from snow. Yeah, believe it or not, that water you used this morning to brush your teeth, it started off as snow in the mountains. We love snow. So to fill a cup full of water, I don't know, maybe you guys have done this experiment before, and if you haven't, today's a good day to try it because there's snow outside. Go outside, scoop up a cup full of snow, bring it inside, and let it melt. Now, raise your hand if you've ever tried this before, where you've scooped up a full cup of water, brought it inside, and let it melt. Has anyone ever done that? Oh, I see some of you are like scientists. You've done this. Good. When you let it melt, that was a full cup of snow. And when it melted, was it a full cup of water? No, right? Because snow also has lots of air in it. So the snow, a full cup of snow, melts down into just a little bit of water. In fact, I challenge you to try this today. Go outside after this talk, scoop up a cup full of water, bring it inside, and then see how much water is left afterwards and measure that. Because, believe it or not, since our snow here in Colorado is so light and fluffy, it has very little moisture content. And so, in fact, I'm looking for my tape measure. Here it is. We have about 10% moisture content in our snow, which means if we want to have a cup of water, that's basically 4 inches of water, how many inches of snow would we need to make 4 inches of liquid water? If our snow is only 10% moisture content, we need 40 inches of snow, right? This much snow would have to melt down to this much water. That's a lot of snow. And there just isn't that much snow on Pikes Peak. That's why we have to go all the way to the really big Rocky Mountains over where the ski areas are to get most of the water that you're drinking today. All right, now snow, of course, comes out of clouds. I thought, wouldn't it be fun if we did an experiment and tried to make a cloud right here in my basement? So let's try it, okay? Now, to do a science experiment, we need to know a few things. First of all, if we're going to try to make a cloud, we need to know what clouds are made out of. All right, who wants to guess? What is a cloud made out of? I am going to, the cattlemen's? Cattlemen's. Yes, there they are.
Mostly water.
Yes, clouds are made mostly out of water vapor, Mickey Mouse molecules in gas form. That's what clouds are made out of. Now, the water molecules need to stick to tiny little dust particles. They need a nucleus. They stick to a little dust particle, and then they gather and gather to where they make a drop right in the cloud, like dewy. So we need a little dust particle. We need a bunch of water molecules in gas form, and then we need some air. Now, do we have clouds every day? In fact, we really only have clouds when there are just the right conditions in our atmosphere. Who here has ever listened to the meteorologists give the weather report on TV before? Anyone ever watched the, yeah? Then maybe you've heard the meteorologists say things like, they're talking about weird things like there's a high pressure system coming. We're going to have sunny skies. Or maybe they'll say something weird like, there's a low pressure over Colorado, 80% chance of precipitation. What are they talking about? Well, here's the deal. In our sky, there is pressure. There's force in the sky. And sometimes that atmospheric pressure is very high. If that's the case, these molecules in the air see each other and they're like, yeah, let's get together and condense and make a cloud. I'm trying to get you, but there's so much pressure. Pushed apart, right? So if you have a high pressure system, you cannot have clouds because the molecules can't come together and condense. You can only get clouds if your atmospheric pressure is low, meaning there's hardly any force in the sky. And then if there's a low pressure system, these water molecules see each other like, yeah, let's get together and condense. Whoa, almost sucked together, right? So we need a low pressure system to have condensation. Okay, so now that we know this, let's try to do an experiment. All right, let's see. We're going to attempt to make a cloud right here in my basement. And let's see, we're going to try to make this cloud inside this bottle right here. Okay, let me make some space on my table. And in this bottle, we're going to try to make the cloud inside here. Now take a look. Do you notice anything about my bottle? Yeah, there's some water in there, right? Tiny bit of water inside this bottle. This bottle is see-through. You can kind of squeeze it a little bit, right? Has a little bit of water in here. All right, we're going to change this water into a cloud. Now, what state of matter is this water in right now? Who can tell me? Ansel, do you know?
Liquid.
Liquid, right. But we make clouds form from water in gas form, water vapor, right? So we need to change this liquid water into gas. So what I'm going to do is I'm going to shake up this bottle like this, and I'm going to get that liquid water to coat the sides of the bottle and jump into the airspace a little bit. So we're going to make some evaporation occur, okay? Well, let's take a look again. I still have liquid water in here, and you can't see it, but now some of that liquid water jumped into the airspace. And it's those water molecules in the airspace that we're going to try to get to condense into a cloud. So here we go. Now, to do this, who remembers what kind of pressure system do we need for clouds? High or low? Show me where your thumbs. High or low? Low, right. Okay, so I'm going to use this pump right here to make a low pressure system, okay? So this is like a foot pump. And I'm going to take the lid off this bottle. The water vapor molecules are in there, along with some liquid water molecules. Now I'm going to make a pressure system inside this bottle, and we're going to see if we get some condensation to occur. All right, let's see. What do you think? Does 10 pumps sound about right? Let's start with that and see what happens. Here we go. You count with me. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what? I don't see a cloud in here yet. Oh, you know what? I can't squeeze the bottle at all. I put so much air in here, I created a high pressure system. We don't want a high pressure system. We want a low pressure system. So what should I do? Oh, maybe I'll let some pressure out. I'll just take the top off and see if maybe then we'll get a low pressure system and a cloud will form. Okay, ready? Keep your eye on the bottle. I'm gonna let some pressure out. Let's see if we get some condensation. Here we go. 3, 2, 1. Oh my gosh, it worked. Do you see it? We made a cloud. Let me see if I put the lid on. We just trapped a cloud inside. We just made a cloud. How cool is that? Oh my gosh, you guys can do this at home. All right, all you need is some container to trap the cloud in. You need some water. I did put in a little bit of dust. And then you need some pressure. So you can use a bicycle pump or whatever. You just have to have a way to keep the pressure inside the bottle. In my case, I attached this rubber stopper to my pump. And then I was able to make a cloud inside a bottle. Now here's a trick for you guys if you want to do this at home. Number 1, do this with an adult. Don't just do this with your little brother or sister and somebody's trying to hold this inside the bottle and then you get too much pressure and the next thing you know it pops out, hits them right in the eye, right? Be safe. Don't do this without an adult. And the other thing is to make this go a little faster, you can do a secret thing like I did. I added a little pump of hand sanitizer into the bottle because the hand sanitizer helps evaporate the water molecules faster. You can do it with plain water, but it'll take a lot longer to get the right pressure. You'll be pumping for half an hour. It's tiring. Add a little squirt of hand sanitizer. Works much faster. Okay, so try this experiment at home if you like. Okay, great. We made a cloud. This is fantastic news because clouds give us precipitation. We want the snow. Now, Colorado Springs Utilities, we like snow because we know where the snow is. It's in the mountains. And so we know what happens to the snow in the springtime. It melts. So we know that if we build our dam at the base of the mountain, our reservoirs will fill with melted snow water in the springtime. So that's why we use melted snow as your water. Now, of course, like you remember, Pikes Peak doesn't have enough snow, so we have to go a long way away to get your water. How many miles do you think we have to go to get your water from? Okay, let's see, Aiden, what's your guess?
At least 50 miles.
More than that, at least 50 miles. We actually have to go further. Ansel, what's your guess?
A lot of the major 14ers and stuff are like a few hundred miles away. So I'd say about 500.
That's a very good guess. Luckily, we kind of just, we go as a bird flies straight to the mountains, we go 100 miles away. We put our pipes in so they're straight. We bury them underground. But 100 miles away, 100 miles. We have to go get your water from 100 miles away. That's where your water's coming from. That's crazy, right? My gosh. All right, but that's what we have to do. Colorado Springs Utilities has to work hard to get you your water. So we hope that you're not wasting it, right? Okay, so I'm going to switch now. Before I switch though, does anyone have any questions so far? Any questions? Let me see if I can see a chat box anyway. Does the dam have a salmon ladder? Oh, this is a good question. Someone asked if our dams at the reservoir have fish ladders on them. And no, they do not. Now, we do have some river diversions where we added fish ladders so that the natural fish can traverse our diversions, but the actual reservoirs themselves do not have fish ladders. And if it's so, let's see, if it's so dirty, you caches could turn into acid rain. Yeah. So I think the question was if the air is dirty, then the rain can turn into something we call acid rain, and that's true. And it's quite a problem. It's mostly a problem in very large cities, not so much in the United States because we have environmental laws in place, but we do have some. But other countries like China and Russia and other places do have issues with acid rain, more so than we do in the United States. Very good. Any other questions? How big is the dam? Well, believe it or not, we actually have 25 reservoirs to store all your water. And so some of them are smaller reservoirs, some of them are larger reservoirs. Our largest dam is probably almost 1,000 feet high and half a mile long. It's very big. Okay, that's the biggest one we have, I think. It's big, big dam. And that would be on Turquoise Lake. We have lots of lakes that are reservoirs that we run for you. Okay, I'm going to switch to a PowerPoint so I can show you some of our infrastructure. Okay, so I'm going to share a screen and let me make sure I'm keeping track of time. Oh, we only have 15 minutes. Okay, I've got to kind of hurry. Let's see, we're going to share this screen. Okay, can you guys, and I can't see you nod, but hopefully you can now see a screen that says Water Wonders. And if for some reason not, hopefully the library will tell me.
Yes, it looks good.
Excellent. Thank you very much, Barb. All right, now if I just need to get this to advance. Great. All right, I'm going to stop share because something's just being weird, and I'm going to try it again because I couldn't get it to advance. So let's try this screen instead. And I'm going to start from the beginning. And let's see if it'll go this time. Yes. Okay, so we just did our cloud experiment and we talked about the water cycle. Oh, I want to have you guys guess. How many inches of precipitation do you think we get in Colorado Springs in an average year, in a normal year? How many inches of precipitation? That's measured in liquid water by us, by the way. How much precipitation? Aiden, what do you think? Say out loud.
I can't really answer this question because I live out in the desert in Colorado.
Yeah,
So-
we're mostly a desert here. That's true. Did you have a different question, Aiden?
Yes. I have a question from my mom.
Yes.
What's the highest paying job that you need right now?
The highest paying job at utilities?
Yeah, that you need another worker for.
Oh, we need workers all the time. Can you believe it? We have 1,800 people working at Colorado Springs Utilities, and we have people that retire, and then we need to hire new people all the time. So check our job postings, and then you'll see what we need, and on there it'll tell you the salary that we pay. So we pay different salaries based on if we need an engineer or a computer specialist or an education person or a lineman or or a line person or whatever the need is. But it ranges generally from between about $50,000 to $100,000 a year, depending on your level of education.
Okay.
All right, thank you. Okay, so who wants to guess? How many inches of precipitation do we get in Colorado Springs in a normal year? I can't see anybody's hands up, so I can't answer this question with my screen. So I'm just going to keep that thought in your head, and here's the answer. Let's see if you were right. 16 inches. That's it. That's all we get in a year. We're kind of dry here. So that makes it even more important that we use every drop as efficiently as possible. Now, how do we get the water to you? All right, let's see. I'm going to see if I can use a little laser pointer. Okay, first we collect the snow melt from the mountains, right? And then we bring it to town, and sometimes we have to use a pump station to help the water get over a hill. Once it gets to town, we send it through our water treatment plant where we take out any dirt and germs and make it safe to drink. Along the way, we have reservoirs to store the water along the way, and then also to store it after it's done being treated. And then Once it's tested to be clean, then we distribute it to all your homes. In fact, we have over 2,000 miles of water pipes under the streets in the city. We have to maintain all of them. And then we get them to you, our customers. And it's delicious water. I hope you like it. It's taken a lot of work to get there. Okay, and I thought it'd be fun if you could see what your water system kind of looks like. So here's a bit of a flyover to show what are your water system a collection system looks like. First things we had to do was we had to buy the right to some of the water up in the mountains. And to do that, we take the amount that we purchased off the natural stream through something called a flume here. And that's measured. Every drop is measured. We can only take as much as we've bought. And then we bring that water through the mountains because most of this snow is on the other side of the state. And there's big Rocky Mountains in the way. And so we had to build tunnels through the mountains to get the water through the mountains to our side of the Continental Divide. Now, once it gets to our side, then we put the water into reservoirs. So here is a picture of one of the reservoirs near the mountains. This is over here by Independence Pass and by just north of the town of Buena Vista. And this is one of our reservoirs, and there's the dam. You see that thing right there? I don't know if you can see my pointer, but there's the dam. And then we have to transport that water all the way from there 100 miles towards town. And then we store it in reservoirs closer to town, like Rampart Reservoir. In fact, this is the dam right here. And to get it all the way to town, we have used pipelines. Now, the pipes are made out of steel, big 50-foot sections of steel that are welded together. Now, the very first pipes that we used, they were put in back in 1950. You can see they're much smaller than the ones we use these days, but we still use that pipe, that one right there in this picture. We still use that pipe. And the newer pipes are much bigger. They're made out of steel. See this person standing right here off to the right? You can see they could easily stand up inside these pipes. They're huge. You guys could run around inside these pipes. Of course, we won't let you in there. They're full of water, but they're really big. Now, the pump stations are built to help boost the water up over hills, and they're filled with these really long, tall motors with like turbine propellers to lift the water. This is an aerial view of a pump station near Buena Vista, and it lifts the water over this hill right here. And then there's another picture of a pump station closer to town. This is the one off of Highway 24 near the town of Divide. And we dressed it up to make it look like a beautiful red barn, but there are no cows in there, just lots of pumps. We just wanted to make it look pretty so it would fit into the neighborhood. And so that's what some of your water system looks like. All right, let's see. Now, once we get the water to town, then we have to clean it. So we have water treatment plants, and these are the 4 steps that we use to make the water super healthy and safe for you to drink. It's a really cool job. In fact, I work right at this water treatment plant. Now, once it's cleaned and we get it to your house, take a look. This is how the water is used in your home. So this is called a pie chart. And the slices of pie have percentages on them. Take a look. Can you see what uses the most water in your home? Yeah, if you said landscaping, 35% of the water in an average home is actually used outside of the home, in the yard, to water the grass and the trees. And that's a lot of water. That's almost like it's more than a third of the water is used outside. Now, inside the house, take a look. Can you see what uses the most water inside your home? If you guessed toilets, you're right. The toilet uses a lot of water. And then close behind the toilet would be the showers and baths. They use 14% of your water. Faucets, like in the kitchen for washing dishes or in the bathroom for brushing your teeth, they use 12%. Then 11% is used for washing your clothes. And then we have this category called leaks and other. Believe it or not, leaks waste almost 11% of all the water used in town is lost through leaks. It's very sad. So if you see a dripping faucet, shut it off. If it keeps dripping after you shut it off tight, then you probably need to fix it. And it could be as simple as just a little washer. Okay, let's see. I don't know that we have time for the wastewater portion. Let's see, we have 5 minutes. Are you guys interested in taking a very fast run through the wastewater system? I see some nods, I think. I'm going to just go.
Yes.
Yes. Okay. We're going to go super fast. And then for those of you that need to get off right at 2, please leave when you need to. And here we go. All right. Wastewater is disgusting. So the first water that comes to the wastewater treatment plant looks just really gross. It's everything that's gone down from your shower, your toilet, your kitchen sink. It all gets mixed together and has gross things in there. So the first step is to take out some of the larger materials. So in this picture here, you'll see like a receipt that made it down the drain somehow. This might be a piece of carrot. It could be an orange peel. This stuff here looks like toilet paper, but it's not. Toilet paper is designed to dissolve in little pieces, and it's going to go through the slots right here with the liquid. This stuff is mostly things like paper towels or flushable wipes. Flushable wipes are not flushable. Please don't believe the marketing. Flushable wipes should be put in the trash can, not flushed down the toilet. Okay, so that's the first step. Takes out the nasty stuff. Then the liquid left over is kind of brown and it doesn't look too good. Believe it or not, we use microscopic organisms to eat the waste out of the wastewater. This is a picture through a high-powered microscope. And we have all kinds of microbes. Some of them are little, like this guy here, and some of them are big, like this one here. And they eat the waste out of the water. This is waste. And they're going to eat it, and they're going to digest it, and they're going to get rid of it for us. And what's left over afterwards is clean water. Yes, so you can thank these tiny little critters that you can't even see with your eye for cleaning up your wastewater and turning it into really clean water. Now, don't worry. These little critters are not in your water. They stay at the wastewater treatment plant where they have to do their job. Once they're done eating, then we take the clean water without the microbes in it. They settle to the bottom of the tank and stay there. And we take the clean water and then we disinfect it with ultraviolet light and then we send it down the stream. So here's our water cycle right here in Colorado Springs. We get your water, let me put my laser pointer on, from the mountains. So this is a little review of what we talked about. We get your water from the big Rocky Mountains through tunnels, into reservoirs, through the pipes, all the way to town. Then we clean it at the water treatment plant, make it safe to drink, and then we send it to your house and you use it. And when you're done using it, the part inside your house will go down the wastewater sewer pipes to the wastewater treatment plant where we take out all the nasty stuff and use the little microbes to clean up the water, and then we disinfect it and then we discharge it to Fountain Creek. Now that water is going to flow downstream to the next town. And the next town is going to take the water out of the stream and they're going to clean it up to make it safe to drink and serve it to their customers. So here's the lucky thing for you guys. Whoops. The lucky thing for you guys, you live in Colorado Springs. So you are the first users of the water, as we say, because you're the first ones to get it straight from the mountains, cleaned up into your house. You're the first ones to get to use it. That's why it tastes so good here. All right, I'm going to do a quick pop quiz. Who wants to guess? What's the main source of your water supply? Is it rain and hail? Answer A. Is it ocean water? Answer B. Is it melted snow? Answer C. Is it groundwater? Answer D. If you guessed C, melted snow, then give yourself a pat on the back. You did good. All right, next question. We have to bring in water from pretty far away. Who remembers how many miles your water has to travel? Is it 10 miles, 20, 50, 100? If you remember it was 100, good job. Pat yourself on the back. All right, one more question. What is most of the water used for by people that live here in Colorado Springs? Is it landscaping, toilets, showers, washing clothes? If you guessed landscaping, you were right and you learned a lot. All right, excellent. We have water-wise rules to make sure you don't waste the water outside. Basically, you're allowed to water outside 3 days a week, no more. And you should water before 10 in the morning or after 6 when it's cooler outside. And you have a homework assignment. All right, I hope everyone can find some food coloring in their cupboard, or if not, the library has toilet testing tablets that I left with them at the East Library you can pick up. And then you can test your toilets at home. What you're going to do is you're going to take food coloring, about 10 drops, or the toilet testing tablets, drop it into the water in the tank. Then you're going to walk away from the toilet, come back 10 minutes later, lift the lid and look in the bowl. The water in the bowl should be clear. But if you see any colored water in there, you have a leak. So please fix it. And it's very easy to do. There's a YouTube video that you can watch. Fourth graders can do this. Okay, I'm going to stop sharing. Any last questions? Oh, you guys did good on your guessing. I see a question from Ansel. Yes.
So I have a few questions.
Yes.
Like, so what is the pH of acid rain that can burn people?
So pH is, as you know, is a scale of acidity. It goes from 0 to 14. 7 in the middle is neutral, and that's what people need for drinking. Once you get below 4, it starts to cause skin irritation. And at 2, it's highly corrosive. So acid rain from the sky is really thing at a pH level of 5 or lower is considered acid rain.
Okay, and what was my other question? Oh, are the microbes that you use for eating the bacteria in water the same microbes? Well, are they like the microbes that a panda uses to digest bamboo?
The microbes that we use to eat the waste out of the wastewater are basically the same kind of microbes that are found in your gut, right? That are digesting your food. So yeah, I would guess they'd probably be very similar to the ones a panda would have in his stomach as well.
Pandas are very strong because bamboo is actually poisonous.
Yep.
And then also, actually, our water is only 10 feet away because we have a well.
Oh, you're on well, so you're using groundwater. Okay, good. The groundwater beneath the city isn't enough to support the city. It doesn't recharge fast enough. So even though we have some groundwater wells, we don't use the groundwater because it would suck it down too fast. But houses can have their own wells, and they don't deplete the aquifer as quickly. So that's good.
Yeah.
All right. Any other questions? I don't see any hands up. Oh, I do. Colin has a hand up.
How many dams do you make a week?
Well, so building dams is very expensive. And the last dam that we built was about 10 years ago. And it took us 4 years to build it. It's a very big dam. So we have 25 dams and we probably won't have too many more. Does that answer your question? Maybe you'll be a dam engineer someday because we need people to inspect our dams every year to make sure that they're still safe and won't break. So it might be a good job for you someday, Colin. All right. Any other questions? My God, you guys were awesome. Okay, so at the library, I have a little worksheet in case you'd like to become a water conservation wizard. You can do the worksheet, and with that, you get a 5-minute shower timer to help you take a shorter shower, and you get toilet testing tablets. And let's see, make sure you use your water wisely and don't waste it. Dewey is counting on you. Okay? All right. Thanks so much, you guys. Have a fantastic weekend.
Thank you so much. What a great presentation. And thanks for coming, everyone.
Bye. Thank you.
Bye.
Good
Thank you.
presentation. Kathy.
Bye.
Bye.
Thanks.
Bye.
Thank you. Bye.